Hey class, Mr. Dempster here. I got Marshall with me. We're going to be looking more at the Pythagorean Theorem and how it works. Marshall just wanted to be part of class today, so you get to see him. He's here with me every day. March 25th, I want to just say thank you everybody for going online, making sure that you're getting those assignments submitted and staying with us. So today we're looking at the Pythagorean Theorem and how it really works. The videos that I sent you looked at the solutions and looked at the formula for the Pythagorean Theorem, but it didn't talk about how it worked so much, so I'm going to go into that today. I'm also going to look at how to structure a solution so you can see how to organize your work, and then remembering that the preservation of equality always does play into all of these. After that, I'm going to ask you to try this on your own, try to find a right angle triangle around the house, or you can just draw one out and then you can use it that way. But we're going to look at how you can send those in to show me after, and we'll get into the other stuff after that. So when we're looking at the Pythagorean Theorem, we're saying that we must have a right triangle. So we're saying that if I have a triangle, and let's just pretend that that's 3 long. Well, that's actually, put that a little lower. So if it's 3 long by 4 wide, we will be able to say that this side, this long side, the side opposite the right angle, so that opposite side, we're going to say that the square of that should be equal to the 2 squares of this. So we're saying, I'm just going to grab that if this were side B, and this were side A, that A squared plus B squared should give me C squared. Okay, so we're going to look at how this actually works. And we said what? That this was, we're going to say B is 3, we said. And we also said A was 4. So when it's saying that this side is 3. And remember, when we're talking about a square, we're saying like the square of 3. So we're saying if I took that and I drew a square that had a root of 3. I'm going to erase my B for now. My root of 3 would be 9. I know that's not perfect. And then I'm going to look at my A, and I'm going to draw a square off that. That has a root of 4, meaning the base, or one side, is 4. Is that square? Not really. And I'm going to split this. So what the theorem is saying is if I add up all the squares here, and I add up all these squares here, it should equal the amount of squares for here. So let's look at the theorem and just see how it works. We're going to look at how it goes into structure as well. So when I know B is 3 and A is 4, what I really do is I fill in, I replace A, or I substitute A with 4, so 4 squared, plus B is 3 squared. And then I'm just going to find out. I don't know what C squared is yet, so I'm just going to say C squared. Okay. And if I want to look at 4 squared and I say, well, how many squares actually is 4 squared, and it looks like it's 16, or 4 times 4 is 16. We know that from square roots and perfect squares. And 3 squared is 9. And again, that equals c squared. Now, before I continue, I just want to really look at how I'm structuring this. I'm really making sure that I'm replacing it, I'm making it all obvious, like the a's all came down here, the b's came down here, and c squared just stayed here because I didn't know it. My equal signs are all in line. This is just how you structure a solution. I then look at what is 16 plus 9, and that is 25. So 25 is equal to that c squared. So I need to get c by itself. So this is where that preservation of equality comes in. And I have to say, well, what is the opposite of squaring a number? It's actually square rooting. So I square root that number. If I square root this side, I also have to square root this side. So the square root of c squared is c. And then the square root of 25 is 5. So when I look at that, I say that that's square. Hey, Marshall. The square coming off c. There should be 25 squares in here. So if I do that, let's see if I can do this one. So we have 5 this way, 5 the other way. I didn't do that perfectly, but if I look, I got a 5 by 5 square gives me c squared, gives me that 25, meaning that this one side right there is 5, meaning that c is 5. So that's how it works. That's what we're actually saying. We're saying that if I took these squares and I added them up, I'm going to get this square. If I take the square root of that, that's going to give me that side. So that's how the Pythagorean theorem works. And now I want you to go and try this on your own. So I want you to try to find a right angle triangle somewhere around the house, or you could just draw one out just like I did. And just measure the sides and see how big each side is. See how it works. See how this theorem works. Last thing, just make sure you're handing in all your assignments on Shobi, and make sure you're finishing your assignments on Khan Academy, and then we'll keep going. You're doing a great job so far. A lot of kids are being active online, and that's what we need to keep doing. So if you have any questions, please let me know, and have a good day.